Okay, guys, so we're going to go through this video. You must make sure that when I say to pause the video, that you actually pause it, you write down your answers. Just pausing it and thinking it in your head is not at all good enough. Okay, this is a very difficult topic and you need to make sure you're practicing it as you go. Okay, so we're going to start off, you're going to write down an answer to this 5-mark question here. So silver reacts with fluorine to form silver fluoride. So read the question. It's just about ionic bonding, what we've done already. Have a go at it. Okay, pause the video. Okay, so the answer. So the first part says state the bonding involved. That's ionic. So I gave that away when I was speaking about it. Second part was asked you to draw a diagram showing how the particles are arranged in a silver fluoride lattice. Show the charge on the particles. So you can see it says a minimum of 4 ions drawn in 2D. What it means by this is it means like this. So you've got to have circles and you've got to have ions. So you've got to have a charge. So that could be the silver positive charge. And here's the negative, what was the negative ion? It was fluorine. You don't have to write the letters in, just having a positive, negative. Now these should be arranged like this, positive, negative. Apologies, my drawing with a mouse is really bad. Better. So it should be arranged negative, positive, positive, negative. And your best ability, they should be drawn the same size and in a regular arrangement because these guys are in a solid. Okay, so you need a minimum of these 4s in a 3D shape to get that mark there. Oh no, sorry, you need a further 3 ions shown correctly in a cube, so you need to have at least a cube structure like this, a minimum of 3 by 3. I've done a 4 by 3, but that's fine to get that mark there. And then you need to explain it because the question asked, explain why the melting point of silver fluoride is high. So it's got strong electrostatic forces between the positive and negative ions, or you could say between oppositely charged ions. Okay, don't worry about this part here. We haven't covered that part there about why that's very wrong. But that basically means if you mention those words, which you've come across molecules before, covalent. These are not molecules. These are ionic compounds. If you use the word molecule, you lose all marks for this question. Oh no, sorry, the marks for 1 by 5. Okay, so what we're looking at today, it says ionic bonding for some reason up there. We're looking at metallic bonding, with ionic bonding. So nature of metallic bonding, properties of metals, and properties comparing and contrast with ionic stuff. So as we know, there are 3 types of bonding: covalent, which is sharing of electrons; ionic, where electrons are lost or gained, forming ions; and metallic is what we're looking at today. So metallic is to do with, this is what metals form. So metals on the periodic table form metallic bonds. And this is when you have metal ions surrounded by delocalized electrons, which can move around freely. So, skip that because you're not. Talk to someone. So, what is metallic bonding? Metallic bonding is the electrostatic attraction. So, similar to ionic bonding, in fact, as I said before, all of chemistry is electrostatic attractions. So, it's the electrostatic attraction between delocalized electrons and positively charged metal ions. Whereas ionic bonding was the electrostatic attraction between oppositely charged ions. You need to have this perfectly in your head. You cannot mix the two up. The only way you can get this perfectly in your head is practicing it, like writing it out again and again until it just comes instantly. There's no easy way to memorize it. You need to put the effort in to do that. Okay, on a piece of paper, can you list as many properties of metals as you can? Think back to key stage 3, what do you know about metals? Pause the video, go. Okay, so you should have hopefully come up with they conduct electricity. They're malleable, that means they can be beaten into shape easily. You need to learn all these words. Ductile, similar to malleable, means they can be drawn into wires. So it's a similar reason for why they can be able to do that. Generally high melting point. An obvious exception is mercury, which has actually a relatively low melting point and is a liquid at room temperature, and they're shiny. But we're not going to go into why they are shiny. Physics. Okay, so make a note of those properties. We're going to go and explain them. So metals are malleable, ductile, because the layers can slide over each other with no repulsion. Very common question. Why are metals malleable? Why can metals be bent into shape? Why can metals be drawn into wires? Answer, because the layers can slide over each other with no repulsion. This is in opposite to ionic compounds, which are brittle. For example, here is an ionic lattice. Positive, negative, positive, negative. If I move one of these layers, say I shift this layer here, say this layer here moves one ion to the left, suddenly we've got negative ions next to negative ions, positive ions next to positive ions. It's going to have repulsion, the whole thing breaks up and splits up. Whereas it does not for metals. I think I've got a diagram somewhere. Maybe not, that's draw it. Oh yeah, here we go. So metals are malleable because the layers can slide over each other. Here are the layers, look at them, they're all positively charged. All of these ions are positively charged, and they're surrounded by delocalized electrons. The electrons can move. If I move these layers, like this, there's no difference. They're still surrounded. All the negative electrons are hanging out between these ions. There's no difference. I can move these layers into any configuration I want. It will not affect the metallic bonding. You're still going to have delocalized electrons surrounding positive metal ions. And remember, metallic bonding is delocalized electrons surrounding metal ions. So it doesn't matter how we bang and shape it, you're always going to have metallic bonding, therefore it's malleable, therefore it is ductile. Okay. Why don't you pause the video now and see if you can write down an exam answer. Why are metals malleable? Pause the video, write down it, try, go for it. Okay, so you should have got, metals are malleable because the layers can slide over each other with no repulsion. Okay, let's talk about high melting points. So we talked about melting points with ionic compounds, very similar. Have a go now. Why do you think metals generally have high melting points? Use the words that you would use when you were talking about an ionic compound having high melting points. It's almost very similar. Pause the video, see how much you get, and then we'll correct it in a sec. Okay, so pausing the video. Okay, so metals have high melting points because they have many strong electrostatic attractions. Do you remember that's exactly the same as why ionic compounds have high melting points? Many strong electrostatic attractions between, very important word, but here, instead of saying oppositely charged ions, like we would for ionic compounds, we say between delocalized electrons and positive ions. And again, we end the same as we would for the other, we would talk about ionic compounds, therefore they require lots of energy to overcome. Come back to this question and practice it until you can do this type of question in your sleep. They will ask you, I will ask you in the exam, and they ask you in the real GCSE about melting point of metals, guaranteed. Okay, why can metals conduct electricity when solid and molten? So think about why ionic compounds could conduct. So just remind yourself, why could ionic compounds conduct when molten or dissolved, but not when solid? What did they need to have? Have a think. Well, metals conduct when solid and molten is a bit different. They don't have any free-moving ions. Well, actually, they do when they're molten, but what they have is better. They have free-moving electrons, which are actually a lot better at carrying electricity. This is why we use metals in wires. So metals contain delocalized electrons. Remember, that's what holds them together with the metal ions, which are mobile charge carriers. Mobile charge carriers which can carry the current. So again, just need to learn this answer. Why do metals conduct? You just need to learn this answer. Okay, off by heart. Okay, we talked about malleability. Okay, can you pause the video, sketch out this table in your books, and fill in why do ionic compounds have a high melting point? So that's going to be about 3 lines. So make sure this table is a whole page big. Why do metallic compounds have high melting points? Why can ionic compounds conduct? Metallic, you get it. Just go through. So why ionic compounds can't conduct actually when solid? So just work through this table, filling it in completely. Just should take about 10-15 minutes. Okay, don't try and Don't skip and watch anything else. Just try and do it all from memory as much as you can, and then watch the answers in now. And there are the answers. So you can go through it. So it's exactly what we've already talked about in this lesson, what we talked about in the previous lesson on ionic compounds. You just need to learn all these answers. Okay, have a go at this one as well. Pause the video, have a go, and here comes the answer. No. Answer is that one, sorry. That was question 1A. There's the answer. Okay, pause the video, try these questions. Let me move my head out of the way. Okay, pause the video and try these questions here. Pausing, answers coming. Oops. Okay, there's the answer to that. The answer to that. This is nothing new, this is stuff we already just did, just looking at some real exam questions. Oops, the answer to that. Remember, I'm sharing all these slides with you as well, so you can go through these at your own pace. Okay. Right, so have a go. Here's another question. So this other question, pause the video, 6 marks. So talk about one. Remember, you must state the type of bonding, state the type of structure for each one, and which one has the highest melting point and why. Remember, ionic compounds generally have higher melting points than metallic compounds. Okay, oops. So pause the video, have a go. And here is the answer in 3, 2, 1. So we stated the structure.